Steel is an iron and carbon alloy that is stronger and more fracture-resistant than other types of iron. Steel is one of the materials that is created most frequently in the world due to its great tensile strength and inexpensive cost. Buildings, bridges, infrastructure, tools, automobiles, trains, bikes, machinery, electrical appliances, furniture, and weaponry are all made of steel, as well as concrete reinforcing rods and other building materials. Steel always has iron as the primary component, yet it can also include or be enriched with many other elements. The corrosion and oxidation resistance of stainless steel usually requires an extra 11% of chromium. A quick reminder to subscribe, like and share this video. What is steel? Iron is produced by removing oxygen and other impurities from iron ore. Iron, carbon, recycled steel, and trace elements make steel. Steel is an iron-carbon alloy with trace silicon, phosphorus, sulfur, oxygen, and less than 2% carbon and 1% manganese. Steel leads building and engineering globally. Our cars, building materials, washing machines, refrigerators, cargo ships, and healthcare scalpels included. Iron is steel's basis. It crystallizes into body-centered cubic or face-centered cubic allotropic forms depending on temperature. The way iron allotropes interact with alloying elements, particularly carbon, gives steel and cast iron unique properties. Pure iron is soft and easily produced because its crystal structure allows iron atoms to move past each other. Small quantities of carbon, other elements, and iron inclusions harden steel to prevent dislocations. What are the properties of steel? The properties of steel include strength, hardness, ductility, toughness, corrosion resistance, thermal conductivity, electrical conductivity, weldability, magnetic properties, and recyclability. 1. Ductility. Steel is easily built or shaped without breaking because of its ductility. This characteristic makes a variety of production techniques possible, including bending, forging, and rolling. 2. Toughness. Steel is able to absorb energy and sustain impact without breaking, indicating that the material has strong toughness. The safety and dependability of steel constructions are enhanced by this characteristic. 3. Thermal conductivity. Steel can transport heat well because of its comparatively high thermal conductivity. Applications like heat exchangers and cooking utensils benefit from this feature. 4. Electrical conductivity. Steel nevertheless has electrical conductivity, even if it isn't as conductive as copper or aluminum. This property makes steel helpful in situations that need for electrical conductivity or grounding. 5. Corrosion resistance. The presence of alloying metals like chromium gives certain forms of steel, notably stainless steel, excellent resistance to corrosion. Steel is able to withstand corrosion and deterioration in corrosive environments and damp conditions because to its feature. 6. Strength. Steel is well known for its exceptional strength, which offers superior load-bearing capability and structural integrity. Its strength makes it possible to build sturdy, long-lasting buildings. 7. Hardness. Steel may be made harder by alloying it or applying heat treatment, which increases the material's resistance to abrasion, wear, and deformation. 8. Recyclability. Steel is very recyclable, which contributes to its sustainability and friendliness to the environment. Its qualities allow for recycling and reuse without sacrificing it, which lowers the need for raw materials and energy usage. 9. Weldability. Steel's excellent weldability makes it possible to join steel components together effectively using a variety of welding techniques. Steel structure assembly and manufacturing are made easier by this feature. 10. Magnetic properties. Depending on how it is made and processed, steel may have magnetic characteristics. Electrical transformers and motors employ special kinds of steel, such electrical steel, because of its magnetic properties. What are the types of steel? 1. Carbon steel. 2. Stainless steel. 3. Alloy steel. 4. Tool steel. 5. High-strength low-alloy HSLA steel. 6. Electrical steel. 7. Weathering steel. 8. Galvanized steel. 9. Miraging steel. 10. Dual-phase steel. 11. Electrical transmission and distribution steel. 12. Spring steel. 13. Nitriding steel. Material used in steel making. The majority of steel is composed of carbon, which typically has a percentage of up to 2%, and iron, which serves as the base metal. Steel contains smaller amounts of other elements, such as silicon, phosphorus, sulfur, oxygen, chromium, and manganese. These additional elements may be included on purpose to change the properties of the steel, such as strengthening it, increasing its durability against corrosion, or simplifying specific production processes. Because iron and carbon are combined, as well as these alloying elements are present in controlled amounts, steel has a unique range of mechanical and chemical properties. Because of this, steel is a flexible material used in a wide range of industries. How is steel made? Steelmaking is the process of producing steel through a series of stages. The most used method is the basic oxygen furnace process, which involves melting iron or in a blast furnace to produce pig iron. After that, excess carbon and impurities are blown out of the molten iron using a high-pressure oxygen jet in a basic oxygen furnace to refine the pig iron. At this stage, the necessary composition and qualities can be obtained by adding other components like manganese, chromium, or nickel. Another technique that uses recovered steel waste as the primary raw material for pig iron is the electric arc furnace EAF process. An electric arc formed between electrodes melts the scrap metal in the EAF. After that, the scrap metal undergoes further purification with the addition of other alloys and suitable chemical modifications. After the steelmaking process, the molten steel is formed into billets, slabs, or blooms. It may undergo additional processing procedures such as rolling, forging, or heat treatment to further enhance its properties before being used in a range of applications. How to heat treat steel? Heat treatment is essential in the metal industry when steel is heated over its change in point from austenite to become martensite. This procedure increases steel brittleness, strength, and form retention. Hardening, annealing, normalizing, tempering, and case hardening are heat treatments. Hardening a metal increases its hardness and strength by heating and cooling it quickly. However, annealing reduces internal tensions, making metal more ductile and improving grain structures. Normalizing ferrous metal relieves internal strains and makes it stronger. Tempering lowers internal tensions and brittleness, improving steel toughness. This is done by heating steel below the lower critical temperature and above it, depending on alloy and application. It generates soft or hard metal depending on cooling rate. Controlled heat makes high-speed steel. If you find this video interesting, don't forget to subscribe, like and share this video.